Exciting developments are unfolding in the AI landscape, and this is more than just buzz. DeepSeek has unveiled a groundbreaking method that enables AI models to enhance their own thinking capabilities, and it's beginning to surpass established players like GPT-4o. At the same time, OpenAI is busy developing a range of new models and has significantly upgraded ChatGPT's memory. It can now retain everything you've shared with it. The pace of innovation is astonishing, making it feel like you're interacting with an AI that evolves alongside you. Now, let's delve into DeepSeek's latest AI innovation. They've named it DeepSeek-GRM, and they claim that once an AI model is trained using SPCT, it can effortlessly manage single, paired, or multiple responses. For instance, if you provide the model with several potential answers, it will generate a brief text that reflects its learned principles, essentially the guidelines it uses to evaluate what constitutes a good answer. It then analyzes each response in detail and assigns a score from 1 to 10. If an answer aligns with its standards for accuracy, clarity, safety, or any other criteria it deems significant, it receives a higher score. Conversely, if an answer appears questionable, it will score lower. What truly distinguishes this system is its ability to perform repeated sampling during inference. This means you can evaluate the model's internal assessment process multiple times and either average the results or take a vote on them. While this may seem a bit labor-intensive, it ultimately leads to more precise final decisions by providing a wider range of potential critiques. To enhance the process, they've implemented a gatekeeper known as the Meta Reward Model, Meta-RM, which screens out any inadequate critiques that the system may produce. This means you're not limited to relying on a single critique. Instead, you can collect multiple evaluations, filter out the irrelevant ones, and arrive at a more informed final decision. Now let's take a moment to delve into the training of DeepSeek-GRM. This training process is referred to as Self-Principled Critique Tuning, SPCT, and unfolds in two distinct phases. The first phase is called Regenerative Fine-Tuning, RFT, which establishes a foundational understanding of what constitutes quality critiques. The principle behind this selective sampling is that if the model's predicted scores do not correspond with the known best responses, those generated samples are discarded. If the model happens to get everything right from the start, those instances are also eliminated, as the focus is on more challenging examples. Additionally, they include some single response data, marking correct answers with a 1 and an incorrect one with 0, which forms the training set for the baseline. For their 27 billion parameter model named Gemma-227B, they employed a batch size of 1024 and a learning rate of 5e6, training for approximately 900 steps on 128 A100 GPUs, which took nearly 19.2 hours. DeepSeek has explored various sizes of its generative reward model, ranging from a 16B version based on a mixture of experts framework to a 27B model built on Gemma's 227B, and even larger versions at 236B and 671B, which also utilize mixture of experts architectures. They emphasize that the 27B model is their standard for showcasing results, likely because it strikes an ideal balance between performative and cost. The standout aspect of this approach is its performance in benchmark tests. In the Reward Bench tests, the 27B version of the DeepSeek-GRM achieved approximately 86.0% accuracy with a single greedy pass, which is already impressive. When employing an 8-sample voting method, this score increases to around 88.5%. By incorporating Meta-RM filtering, the accuracy can even reach 90.4% in that specific area. In other evaluations, smaller yet significant improvements were observed. For instance, PPE preference scores increased from 64.7% to 65.3% or 67.2%, while PPE correctness improved from 59.8% to 63.2%. Overall, a single pass yields an average score of about 69.12%, but with the 32 sample voting combined with Meta-RM, this can rise to 72.88%. Remarkably, these results surpass those of several other large public reward models, such as the Nemotron-4-340B R reward, and in some cases, they even match or exceed the performance of GPT-4o. This system, while impressive, is not without its flaws. It can struggle with tasks that have a single correct answer, such as mathematics or programming, partially when no reference material is available. However, when provided with accurate solutions, it can achieve over 90% accuracy in math, nearly rivaling specialized models. Nevertheless, the generative method remains adaptable for various applications, from chat assistants to safety evaluations. For those seeking greater accuracy, repeated sampling can be employed, allowing Meta-RM to filter out inaccuracies without the need to retain a larger model. The company is yet to provide any official updates regarding R2's launch date or whether it will include the functionalities outlined on recent paper, but the community is buzzing with anticipation. Ultimately, this entire framework is about creating smarter, more versatile models rather than simply scaling up. DeepSeek trains its models to self-evaluate and enhance in real time. While it may not always be the quickest approach, particularly with sampling, it offers richer understanding and great control. DeepSeek is making headlines with its self-enhancing models, and OpenAI is also preparing for some significant developments of its own. They are set to unveil a series of new AI models shortly, with GPT-4.1 leading the charge. This upgraded version of GPT-4.0, their premier multimodal model, is designed seamlessly to integrate text, images, and audio in real time. GPT-4.1 aims to refine the existing capabilities, promising enhanced performance across various applications. Additionally, there are whispers that OpenAI will introduce mini and nano variants of GPT-4.1, likely tailored for speed and optimized for lighter devices. They are also working on a model referred to as O3, along with an O4 mini that could be released even sooner. An AI engineer has reportedly found hints of these models in a web code of ChatGPT, suggesting that these developments are more than mere speculation. An announcement could come as early as next week. Now here's the exciting part. Sam Altman has revealed that ChatGPT's memory feature has seen significant upgrades. It can now retain all your previous conversations, not just snippets of content, allowing for a more cohesive dialogue. This enhancement means that your interactions with ChatGPT can build on past discussions, resulting in responses that feel more personalized, relevant, and genuinely human-like. Previously, the memory feature has had its limitations and was introduced in September of last year for users on free, plus, team, and enterprise plans. However, it has now significantly improved. ChatGPT can now draw on your previous conversations to offer personalized advice, assist with writing, and facilitate learning, all tailored specifically to you. Sam remarked, "This is a surprisingly great feature," suggesting that it represents a move towards AI systems that evolve alongside you, functioning as a personal assistant that becomes more attuned to your preferences over time. Currently, this feature is being rolled out to ChatGPT Pro users, with Plus users set to receive it shortly. Users on Enterprise, EDU, and Team plans can expect it in the upcoming weeks. However, if you reside in the EU, UK, Switzerland, Norway, Iceland, or Liechtenstein, you won't have access to it just yet. As for free users, there's no update available at this time. You remain fully in control of this feature. If you prefer that ChatGPT doesn't retain any information, you can easily opt out through your settings. There's also a temporary chat mode that ensures no memory from your conversation is stored or used. You can review, manage, or delete what it remembers whatever you wish, so there's no pressure. You have the final say on what it retains. So, is this a remarkable advancement, or are we coming too accustomed to AI keeping track of everything we say? And if AI can now evaluate, critique, and develop independently, are we still the ones in charge?